This devlog was supposed to just be about adding a day-night cycle to my bushcraft survival game. I did end up doing that, but I also added dynamic lighting effects, wind, rain, more plants, improvements to the ocean and waves, a golden hour effect for sunrise and sunset, dynamic shadows, and some other stuff. As much as I do need to get to the actual survival mechanics of this game, I wanted to focus all my efforts for this chunk of work on just improving the vibes. One of my main goals for this game is to create a world where you can just stop and relax and enjoy the atmosphere between trying to survive. We'll get to all the new stuff soon, but I'm starting off by showing you an example of near maximum vibes with all the new stuff that has been added. We have the player starting a fire in the dying light of the day among a gentle breeze and light rain. Soon enough, the player is consumed by a near total darkness, broken only by the light of their weak headlamp and the small fire. I'll show more of the work I've done as we progress through the video, including the work I did for the ocean, which is probably the most ridiculous technique I've ever used that actually worked. But let's start by talking about how I implemented the day-night cycle. This is a top-down game, so conveniently we can't actually see the sun, which means at a basic level, all I need for a day-night cycle is for the world to cycle between light and dark. Originally, I tried to use Phase's Lights plugin to achieve this. This can be a great option and initially looked promising, but in order for an item in the game to be affected by the Lights plugin, you need to call setPipeline so that it uses the Light2D pipeline. Since I have so many items in my game, this immediately killed performance. Instead, I decided to go with the highly technical approach of just drawing a big black rectangle over the entire screen and changing its alpha value to make the world lighter or darker. This works quite well, but unfortunately I don't just want a global darkness, because certain things should emit light. But we can just use a little trick to deal with this. Instead of having our light sources emit light, we can instead just have them remove darkness around them. I did this by creating a mask around the light source that would remove that section of the darkness overlay. I created a render texture for the darkness so that it can be dynamically updated, and then each frame I update this render texture so that the darkness has the appropriate sections cut out by the masks. Just using a solid circle doesn't look very good, so I created some sprites with soft edges so that it created a convincing fade out effect for the lights. I also created a different shaped light for the player's headlamp so that it can shine a narrow beam of light out from wherever the player is. And I also had to make sure anything on fire applies a mask to the darkness overlay as well, and that it updates its position as the fire moves. This is by no means the most technically advanced or realistic lighting system you'll ever see, but it is performant and I'm happy with the results for this game. The lighting definitely adds to the vibe of the game, but what I felt the game was lacking the most in terms of the general vibe and feeling was that there was no wind. All the plants were just completely static. Speaking of plants, I also added a few new ones. I added these golden wattles with both flowering and non-flowering varieties, some groups of younger gum trees, and these paperbark trees that will serve an important survival purpose soon. I wanted a convincing wind effect, but I absolutely did not want to have to create hand-drawn pixel art animations for every single tree I add to the game. So it was time for some more shaders, and again with some help from ChatGPT, because my GLSL knowledge is only very basic, I was able to create the effect you see on screen now. The key thing I was aiming for here, and the most challenging thing to achieve, was to make it so that the branches toward the top of the tree would sway, while the bottom of the tree remains mostly static. It's not perfect, of course, but I think the effect is reasonably convincing and definitely helps add the feeling of wind to the game. And since I'm using a shader for this, I don't need to do a ton of work for each sprite, and it is also configurable, so I can quite easily add in more wild weather with strong winds and rain. Rain is another thing I added, which was actually done with a combination of shaders and just normal particle emitters. The heavy rain effect we are looking at on screen now is achieved with a shader that darkens the screen and adds in these rain lines that move around. But I also have a particle emitter emitting simple pixel art rain droplets. If I turn off the shader and just have the particle emitter, we get a more gentle light rain effect. And then that brings us to the main thing I worked on, which was improving the waves and ocean. This has been a big source of frustration for me. I just haven't been able to get something I really liked, and for this chunk of work I ended up spending the vast majority of my time working on this, trying to fix it. For the same reason as the trees, I wanted to use shaders for the ocean so that I didn't have to manually create a ton of pixel art animations. This is what I started with before this devlog, which I think is okay, but I just wasn't really feeling it. I played around with the shaders and ended up with this, which I think is better, but there was a fundamental issue with this approach. I wanted the ocean to be partially transparent, and with the shader approach I was using, this just wasn't all that practical. I can't just set the alpha of the object in phaser. I need to handle the transparency in the shader itself. And in order to display what is behind the shader in the game, I would need to pass that texture into the shader. At first I thought I could perhaps just render the result of the shader to a render texture each frame, and then I could just easily set the alpha on the render texture. This actually kind of worked, but there were some issues and it was all quite computationally expensive for something that probably didn't really need to be. So that's when we get to the weird technique I ended up using. I figured I didn't need to actually execute the shader at runtime. What I really wanted was to take the results of the shader and have that as a normal texture and animation. So what I did was just take a screen recording of the shader animation playing, then I used FFmpeg to export a bunch of still frames from that recording, and then used those to create an animation of the waves in Sprite. The end result is similar to what I was doing with the shader, but much more performant, and most importantly, it supports transparency. This would allow me to quite easily display things underwater, but that's not actually what is happening here for the player sprite, where the parts of the sprite that are under the water fade out. For this, I used a bitmap mask that starts with solid white and then fades to transparent, and the position of that mask is adjusted based on how deep the player is in the water. I also added this little ripple animation where the player enters the water to make it look a bit nicer. Overall, I'm pretty happy with the ocean now, and now that it supports transparency, I'll be able to more easily add things like reefs and rock pools that are exposed as the tide goes in and out. There's a lot more I'd still like to add to the atmosphere of the game, but for now I think it's time to switch gears into really focusing on the survival and gameplay mechanics for the game. If you'd like to follow along with that, feel free to hit subscribe before you go, and I hope to see you back here again for the next video.